manager asks for a simple report combining sales performance with customer satisfaction scores. It should take minutes, but instead you spend 3 days wrestling with 5 different systems that don't communicate with each other. In many organizations, data is like water stored in separate, unconnected buckets. The marketing team has one bucket, the sales team has another, and finance has a third. This separation doesn't just waste time, it can cost your organization millions in missed opportunities and poor decisions. You have the data, but you don't have the complete picture. In this video, we will define multimodal AI and recognize its value by identifying real-world applications where combining data types leads to superior outcomes. This is the exact problem that multimodal AI is designed to solve. Multimodal AI creates systems that can understand and connect information from different data types or modalities at the same time. Think of it like how you understand the world. You don't just read words on a page. You also see images, hear sounds, and feel textures. You combine these inputs to form a complete understanding. An AI that only understands text is a single-modality system. It's useful, but its view is limited. A multimodal system, however, can look at a product photo, read its text description, and analyze customer review videos to get a deep, human-like understanding. It breaks down the walls between your data buckets. So why is this so critical for your role as an AI engineer? Because combining data types doesn't just add more information. It creates entirely new value and solves problems that were previously impossible. Let's look at a real-world example in manufacturing. Imagine an assembly line with a critical robotic arm. A single-modality system might monitor sensor data. It sees that the machine's temperature is rising, but it doesn't know why. This is a symptom, not a cause. The system might trigger an alert, but it's too late. The machine is already close to failure. This leads to unplanned downtime, which can cost a factory over $100,000 per hour. Now, let's apply a multimodal approach. The AI is connected to the same temperature sensor, but it also has access to a thermal camera feed and an audio sensor. The AI sees a specific hotspot on the thermal image of a motor bearing. At the same time, it hears a high-pitched whining sound that has increased in frequency over the past 48 hours. By correlating the thermal data, the audio data, and the temperature spike, the AI doesn't just see a problem. It diagnoses the exact issue: a failing bearing. It predicts the failure 72 hours in advance, allowing for scheduled maintenance. This prevents costly downtime and turns a reactive process into a proactive one. Let's consider another case in e-commerce. A customer wants to buy a specific style of chair they saw in a magazine. They don't know its name. A text-based search is useless. An image search might find visually similar chairs, but not the right one. The customer gets frustrated and leaves your site. With a multimodal system, the customer uploads the photo and adds a text query: "Find this chair, but in a dark blue fabric." The AI processes both the image of the chair's shape and the text specifying the color and material. It returns the exact product instantly. This simple interaction can increase conversion rates by over 10% and significantly reduce product returns from customers who bought the wrong item. The system didn't just process data, it understood the user's intent. In both of these examples, the magic isn't in any single piece of data. It's in the connection, the synthesis, of different data types. Multimodal AI allows you to build systems that see the world more completely. They can identify patterns, understand context, and make predictions that are simply out of reach for single-modality systems. As you move forward, start thinking not just about the models you can build, but about the data you can connect. The most powerful AI solutions are often built at the intersection of different modalities. Think about your own work environment right now. Where are the disconnected data buckets? What critical business problem could you solve if your systems could see, read, and listen at the same time? What is the real cost to your organization of not connecting these different data streams? Answering these questions is the first step toward designing truly intelligent solutions.